Hey guys, I'm just going to run through nice simple heat loss calculations, just calculating the total heat loss for a single room. First I'm going to look through the formulae or formulas that we're going to be using for this heat loss question. We're going to be looking at the example question, hopefully similar to something you've seen before. We're going to do a wee 3D visualization of the building just to help some people get a better idea of what it is that we're actually calculating. And then overall I'm going to be doing a step-by-step walkthrough of the solution. There may be certain parts where I'm doing it in a kind of slower extra set of steps than you could, but I just want to go through kind of every single step possible just to give you an absolute fully rounded idea of what's going on. Anyway, so let's get into it. Firstly, we've got our formulas. So on the left here, this big one, this is just our total heat loss formula. So QT equals the sum of AU plus CV all multiplied by delta T. Down here in this box, I've got a wee explanation of what each thing is. So that funny Greek symbol followed by brackets AU is our sum of AU. CV, that's our ventilation conductance, and delta T is our temperature difference. And that's going to be the temperature difference between the room we're calculating the heat losses for and the outside world. Okay, so down below it here, I've just got the same formula again, but what I've done is I've given you a breakdown of each section of it. So I've broken it up into three chunks. Firstly, we've got the sum of AU. If I go up here, I can see that the sum of AU is equal to A1, U1, so A1 multiplied by U1 plus A2 multiplied by U2 plus A2 multiplied by U3 plus A4 multiplied by U4 and so on. So this is kind of dot 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 plus AN UN just means that kind of goes on forever for as many fabrics as you have in the room. So fabrics mean surfaces, so you could have basically any amount of surfaces in a room and this calculation will still work for it. Okay, secondly onto the CV. So the CV is our ventilation conductance, as I said before, and we're going to calculate that by doing NV divided by 3, where N is the air changes per hour and V is the volume of the room. Over here you also have a way of calculating N if instead of N you are given just a fresh air flow rate, or Q. We're not going to do that today, so I'm just going to scrub this out and forget about it. And then finally we've got our delta T, which is going to be delta T is equal to Ti, which is our inside temperature inside the room we're calculating for, minus To, which is our outside temperature. So there we go. What we're going to do is we're going to break down this QT formula into nice wee easy chunks. You might have noticed there's this other guy hiding here. That's our modified U value. So our U value, which features in the sum of AU, is going to be our thermal transmittance, or basically how well that fabric conducts heat. The higher the value for that, the faster we're going to lose heat through that fabric. The modified U value only factors in for internal partitions. So if you've got an external wall, you don't care about the modified U value. If you've got an internal wall, you're going to have to calculate that because we're going to have slightly less thermal transmittance than we normally would because it's going into a room that's going to be hotter than the outside world. If that doesn't make any sense, don't worry about it. It will once we start going through it. Excellent, right? Now on the right hand side, we have a table 6.3, new buildings maximum U values for building elements. This is taken from the Scottish Building Regulations. And basically what it does is it gives us maximum allowable U values for different fabrics in a building. We import and note these all pertain to external fabrics. Okay, so internal walls, we're going to have to find modified U values for, and we might be given alternate initial U values from the question that will be much higher than these, but these specifically apply to external walls, external or ground floors, roofs, and then we've got windows there. There's two columns to this, which some people find confusing. There's A and B. A is the area weighted average and B is the individual element. Best way to think about it is A, this is the one you want, this is the actual U value that the thing's going to be. Individual element is like, see if you were making a window and you wanted it to be an average U value of 2, what this is saying is you could get away with maybe certain small parts of the window being as high as 3.3, but as long as other parts are lower, say down at like 1 or something like that, and it balances out to an average of 2, then that's fine. But for our purposes at the moment, we don't actually care about this column B, so we're just going to skip it. All we're doing is taking some new values from this column A. Sorry. So for question 1, we're going to calculate the heat loss or the heat load given the following data. So firstly, we've got the outside air temperature of -4 degrees Celsius. Total area of the window has been 25 meters squared. Now, because there's 2 windows, basically what we're going to have to say is that one window will be half of that and one window will be half of that. So that's going to be sizes of 12.5 and 12.5. It's madness that my pen is running when it's not even a real pen. Okay, then we've got the ceiling height for the room. We've got the door dimensions, so that'll be for this wee door over here. Excellent, we've got our air changes per hour, so that's going to be our N value, which is good because it means we don't have to do that extra flow rate calculation. We've got some internal U values down here. Keep in mind, because these are internal values, we're also going to have to modify these. So these initially look really high, like we're going to get a lot of heat losses through that, but once we've modified them, they're going to be absolutely fine. Okay, next it tells us the room immediately below room A is maintained at 17 degrees Celsius, and the room immediately above room A is maintained at 22 degrees Celsius. So this means that the floor to room A will be an internal floor, and the ceiling will be an internal ceiling. You might notice that we have an internal floor U value, but there's none for an internal ceiling. This is because internal floors, if you go to the room above room A, the ceiling of room A will be the floor of the room above. So internal ceilings just get the same U value as internal floors. So just say that's the same as the ceiling. As well. Cool. Excellent. And I think that's us covered everything, and we are ready to go. It doesn't give us, actually, yes, so you might notice that it doesn't give us the U value for the windows or the U value for the external wall. But keep in mind, we're going to get those values from that table we looked at a second ago here, which I've scribbled all over, but that one from the building regs. So your external wall U value would be 0.27 and our window would be 2. Okay, so any values that aren't in that question information, don't panic, they will be in that other set of data we've got. Okay, so let's lay out the steps of our calculation. This is going to be a really easy calculation to do in terms of the maths involved. It's going to be really difficult and laborious in terms of how many different wee bits you're going to have to do along the way. So to make sure we're staying organised, the first thing I'm going to do is label all of my surfaces. Then I'm going to calculate the modified U values for the surfaces that need it, which will be any internal surfaces. Then thirdly, I'm going to calculate my fabric losses. So that's the heat conducting out of the walls, windows, doors, floors and ceilings. Number 4, I'm going to calculate my ventilation losses. So obviously fresh air is coming in and old air is going out of the room. And as that old air goes out, it's going to take away some of the heat with it. We're going to have to heat up that new air, so that's going to cause heat losses. And then finally, we're going to put all that stuff together and calculate our total heat loss for the room. So looking at our diagram from the question, we can see we've got room A to be maintained at 22 degrees Celsius. It's an 8x8 room. It's got 2 windows. It's adjacent to another room of 20 degrees Celsius, another room of 19 degrees Celsius. Then as the question told us, there's rooms above and below it. I've got a wee compass here on the bottom left. The reason I've got that compass is because I'm going to label all my walls and windows and things like that. Stuff like wall north, wall east, wall south, wall west. And the reason I'm going to do that is because it can get quite confusing which one's which if you're just say numbering them and things like that. So I've just said the top one's north, the bottom one's south, etc. And that's when I'm going to label it. Obviously you can label it in whatever way you want, just make sure it's something simple and systematic so that you can go through it and say, oh wait a minute, I'm missing my south wall, or I'm missing my north wall, or I'm missing the east window, that sort of thing. Okay, so just before I label these, what I'm going to do is I'm going to throw up a wee 3D visualization of the room, because I think one of the places people are getting confused with this is they're trying to calculate the areas of the walls and things, but they're struggling to kind of see this as a 3D room, and instead of multiplying the length of the wall by the height of the room, as you would find the area of a wall, they're doing stuff like multiplying the length by the length of another wall. So they're just seeing the two 8s, or the two 8 meters on the diagram. They're going, oh, the wall, right, okay, 8 times 8, and then they're confusing themselves. So we'll do a wee 3D visualization of the room, and then we'll carry on with our labeling. So here we've got a visualization of our wee room from the question. If I do this, we can see it's just a wee 3D mock-up of the same question we're looking at. Okay, so if I just add some colour to this one, there we go. And see, you've got my room A, and then I've just got a wee kind of mock-up of the adjacent rooms as well. So I'll try and zoom in here, and I just, whoop, up. So here we are inside the room. Now, what I'm going to be doing for this room is I'm going to be calculating the heat losses through every surface that I can see inside this room. So to start off with, I'm going to calculate that north wall here. Again, I've just said the top of the drawing is going to be north, so this will be my north wall. Then over to the side, I'm also going to calculate my east wall. And then back here, I'm going to be doing my south wall. And then over here on the left, I'm going to be doing my west wall. And obviously, if I'm doing the walls, I'm also going to be doing the floor. A nice wee floor there. And if I'm doing the floor, I also have to do the ceiling, which is obviously going to be the same surface area as the floor. Cool. Then not to forget, I need to do the windows as their own separate surface, because they'll have a different U value from my external walls. And also not to forget, if my internal door here has a different U value from the wall, I'm going to have to do that as its own separate surface as well. Okay, so just a wee 3D view of what we're going to be doing today, just to make it a wee bit easier to kind of visualize where we're getting the different areas from and the surfaces of the room. Excellent. So now we're just going to label the rooms and all the surfaces. Label the rooms. We're going to label the walls and all the other surfaces. So here, I'm just going to call this like wall north. This one, wall east. Just check my wee compass as a cheat because I get these confused sometimes. Then here, wall south. And you might be thinking, that seems mental, why are you not calling it south wall, east wall, whatever? And it's just for me, I feel like when I've got them kind of in a table together, it just makes a wee bit more sense to me if I've got all the walls kind of coming first and then their direction. But whatever works for you, as I said, you're free to do whatever you like. This wee guy I'm just going to call door, just because there's only one door. If there's multiple doors, I would label them different things. The window, just so I've got a different letter it starts with, because sometimes what I'll do is I'd abbreviate, say like wall north to W lower N. So because of that, what I'm going to do is I'm going to refer to the windows as glazing or glaze. So I'm going to call that glaze north. Now I'll probably change this as soon as I jump to the next table in the slide, but don't worry about it. Just trying to give you ideas of different naming conventions you can use, just so that you stay free of confusion. That's what I'm trying to say. Okay, glazing east, and then we've got the floor. Okay, what I'm going to do is I'm going to draw a wee down arrow because I'm also going to have the ceiling for the room. No, if I could spell, it's really hard to write with this. A wee up arrow, right? Okay, so the floor and the ceiling, they're going to be the same area because ceiling above the floor. You get the idea. Okay, so I think we've got everything. So let's go through. A lot of stuff on the screen. Don't panic. Top left, I've got a wee map of my room with my little compass, so I don't get confused. Bottom left, I've got the different variables for my modified U value. I've got my modified U value, my inside temp, my internal temperature of the adjacent room, the outside temp. Then to the right of that section, I've got U apostrophe equals U brackets ti minus ti apostrophe over ti minus to. I think that's an apostrophe anyway. I always get confused with the wee grammary symbols. Anyway, on the right hand side I've got my data from my question. So I've got the outside temperature, total area of windows, ceiling height, door dimensions, U values, and in the bottom I've got the adjacent temperatures for the upper and lower rooms. Let's see what I'm going to need. I'm going to need my outside temperature, -4. Total area of windows, I don't actually need that at the moment. I don't care about the areas. Don't need my ceiling height. Don't need my door dimensions. Don't need my infiltration rate, so I'll just score this out because it's irrelevant information. U values, I will need those because I'm going to use those to calculate my modified versions of those values. So let's just take something as an example. Now, north wall and window, can't use those because they're external. Same with the east wall and window, they won't have a modified U value. Well, I'll say they won't. If you ever get confused as to what you need to do modified U value calculations for and what you don't, a simple way to think of it is modified U values are just for internal partitions. But if you did use it for the wrong thing, if you used it for an external wall, the U value and your modified U value would just come out the exact same. So there wouldn't be any negative consequence, you'd just be doing extra maths for the sake of maths. But if, say, the external wall was 0.27, if I throw it into that modified U value calculation, which you're free to try yourself, you're just going to get the same value of 0.27 out, right? Okay, so okay, let's take this west wall here. So wall west. Okay, so what do I need for that? I need the U value. So U value, internal wall, is going to be 2. Nice and easy. TI, that is, it's really hard to see on this, but that's temperature inside the room, which is going to be 22 degrees C. TI apostrophe is the temperature in the adjacent room. We've got hard to see here, but it's going to be 19 degrees Celsius in that corridor. Okay, and then my TO, I get that from the question, -4 degrees Celsius. Excellent, right. So for all my modified U value calculations for this room, the TI is always going to be 22, the TO is always going to be -4. The only things that will change are the initial U value and that TI apostrophe, depending on what room it's adjacent to. So let's give this calculation a shot. I can say my modified U value equals the U value of 2 multiplied by bracket TI, which is 22, minus TI apostrophe, which is 19, divided by TI, which is 22, minus the outside temperature, so that's minus a minus, so that's going to be +4, or -4, it will come out the same answer. So 22 minus 19 is going to be 3, times 2 is going to give us 6, divided by 22 plus 4 is 26. If I punch that into my calculator, 6 divided by 26 gives me 3/13, or 0.231. 0.231. Cool, there we go. And that's my modified U value for the west wall. So there we go, we've got our west wall that we just calculated. Oh, if I can draw. Which has our modified U value of 0.231. The south wall has come out as 0.154. Notice the U values were the same for the south and west wall. Internal temperature is the same because it's going to be the same room. All the internal temperatures will be the same. The TI apostrophe, so the temperature for the adjoining room, for the west wall was 19, but for the south wall it was 20, which makes sense because the room south from our room is 20 degrees Celsius. The TO, same for every room, -4. So U value for the south wall, 0.154, 0.231 for the west, which makes sense because we'd expect to see slightly less heat transfer from room A to the south room because it's only 2 degrees of a difference, whereas from room A to the west room we're going to have 3 degrees of a difference, so slightly greater heat transfer on those. So excellent, everything checks out so far. For the door, we've got the same internal and adjacent temperatures and outside temperatures as the west wall, but a slightly higher initial U value, so again slightly higher modified U value to factor in the slightly higher heat transfer. Again, makes perfect sense. Through the floor, 1.8 initial U value, TI of 22, TI in the room below is 17, minus 4 the T outside. So there we go, we've got quite a big 0.346 there. Curiously for the ceiling, we've got 1.8 initial U value. The temperature in the room is still 22, obviously. An adjacent room, as we got from the question, is 22. So if I jump back, we can see for that room immediately above, it's going to be 22, which means we get a modified U value of 0, which actually makes sense when you think about it. If it's 22 degrees Celsius on either side of that floor, heat moves from a high temperature to a low temperature, so if they're the same temperature, there's no heat transfer, so our modified U value becomes 0. Now, some of you might be wondering, why is it 1.8 for the ceiling? Where did I get that from? The question gives us the floor, but where does our ceiling come from? But remember, internal floors and internal ceilings, they're going to be the same U value, because the floor for room A is the ceiling of the room below. Likewise, the floor for the room above room A is going to be the ceiling of room A, so they're going to have the same U value of 1.8. Then obviously it gets modified to 0 because there's no heat transfer through that ceiling. Yeah, makes sense. Okay, perfect. So now that we've got our modified U values, what we're going to do is we're going to carry those over and use those to help calculate our fabric losses. So for our fabric losses, we've got the sum of AU, which we're going to find by finding the area of each surface and multiplying it by its corresponding U value, or modified U value if we found one for it. Cool. So looking on the right here, I've got my U values at the top for my external fabrics. So remember, those are the ones taken from the building regs, which basically just say this is the highest you're allowed your U values to be on external surfaces. For internals, I've got my modified U values in the orange section, which we've calculated. And then down on the bottom, I've got my notes on my areas for the windows. I've got the ceiling height, door dimensions. I've got my infiltration rate, which I don't actually need at the moment, so I'm just going to cross that out. Then we've got our U values for internal partitions, like walls, doors and floors. Again, we've already modified those, so we don't need those anymore. We're not going to put any of those into this question, because our U values are going to come from either the external at the top or those modified U values that we've calculated. So what I'm going to do is I'm going to go through making a wee table. So I would suggest when you're doing the calculations, you actually drop a wee table like this for yourself as well, because the most important thing with this calculation is it's easy, but it's laborious, and there's plenty of places for you to trip up and make mistakes. So on the very left, I've got a section that says notes. I'll explain what that is last. Secondly, I've got surfaces, so this would just be my surface. So for example, say I was going for the, what will I do? I'll do the north wall. So wall, brackets, N for north. I've got a length, so the length for that north wall, what's that going to be? It's going to be 8 meters from side to side. Perfect. This is one to watch out for. Sometimes people get confused when they're looking at the 2D layout of the room. That's why I tried to show you that 3D version. If you remember, this wall is area, it's going to be 8 meters long, but the height of it is going to be the height of the room, which is our ceiling height, which was given to us as 3.5. 3.5. So I've got a section that says holes, e.g. doors. So what I'm saying here is I might have sections of that area of 8 by 3.5 which isn't the wall or isn't the floor or whatever. Now I've got a window in this wall, so what I'm going to have to do is deduct the area of that window. So my windows was given as a total of 25 meters squared, but I've got two windows. So what I'm going to say is one window equals 28, oh sorry, get my numbers wrong, 25 divided by 2, which is going to give me 12.5 meters squared. Okay, so if I'm deducting anything from this surface, I'm going to deduct that 12.5 because that window is effectively a hole in the wall. So my total area, the way I'm going to calculate that is I'm going to do length times height, 8 times 3.5, and then I'm going to deduct 12.5 because 12.5 of that area is actually a window. It's important to use your brackets here because if you don't, actually for this question it doesn't actually make a difference because your calculator will multiply first, but for other questions it might start multiplying when you want it to add first, for example the last heat loss question. So I'd always stick your brackets in just to be safe. Anyway, so 8 times 3.5 gives me 28 minus 12.5 gives me 15.5 according to my calculator. 15.5. So stick that in there, 15.5. Excellent, cool. Now U value, because this is an external wall, I just have to go and find what it is in the regs. So there we go, we've got 0.27. 0.27. Modified value, I'm just going to put a dash here. The modified U value for this, if I calculated it, would work out the same at 0.27. And obviously we don't need a modified U value because it's an external wall, for that reason they would come out the same. So anyway, AU is nice easy calculation finally, where I just multiply 15, or the area, 15.5 by the U value of 0.27, and if I stick that in my calculator I'm going to get 0.27 gives me 4.185. Cool, and I'll put that in there, 4.1885. And then what I'm going to do is I'm just going to go and I'm going to do that for each surface in the room. So I've got that external wall that we just did. I'm also going to have window 1, window 2, that other external wall, the south wall, the west wall, that door, then I've got the floor, and I could do the ceiling as well, but I can just leave the ceiling out because it's going to have 0 heat transfer. So anyway, let's go and look at that table filled out. So there we go, I've got all my AU values filled out in the very right there. This notes section, which I said I'd come back to, you'll notice, so see if we look at the north wall, which is the first one we just did there, the notes I put down are external plus window, and the reason for that is just to make sure that I haven't missed out the window in terms of my minus over here, and the window is just, the external is just so that I remember I'm using the modified U value, and I'm using the regular U value, and there's not going to be a modified U value. For my east wall, I've just done the same again, external plus window, just to kind of factor in that window there and that it's kind of on the outside. South wall, factor in its internal, so remember I've got modified U value. West wall, I've written internal plus door, just so that I remember it's got modified U value, and also I'm deducting that number 2. Is actually just had to retake this part of the video because as I was going through I realised that I initially hadn't factored in that minus. So I went back and redid my calculations, which only took 2 seconds because I've got it in a spreadsheet, which I'll show you later. But yeah, so that kind of shows you how important the notes are. Makes it really easy as you're going back through to kind of make sure you haven't missed anything. Notes for my windows, for my north and east window, I've got area equals half of 25, just because I was given a total glazing of 25, so I just need to remember to half that, which I've done because I've given my area as 12.5. For each, again, no modified U value for either of those because they're external. My door, internal, modified U value, got my dimensions right, and then ceiling, my note for that is same temperature both sides, just so that I know that my modified U value should come out as 0 and my AU for that is 0. So my sum of AU is going to be 91.36, and all I've done for that is taken each AU for every surface and just went, say, 4.185 plus 4.185. That makes sense because both those walls are the same dimensions with the same windows cut out, so they should have the same AU. My internal wall south, adding on the 4.3 there. Wall west, adding on my 6. This is quite interesting, I've actually got bigger heat losses from my internal walls, but again that's because most of this outside's window. My windows, got massive AUs for those. Little tiny AU for the door, and then finally for the floor. So if I add all those up, I should get 91.36. If you've got a slightly different value from rounding, don't worry about it, don't panic. As long as yours is about 90, you're probably correct. Brilliant. So that's us got our fabric losses. Now, the other thing we need is our ventilation losses. So let's go take a look at those. Now, I'm just giving the answer straight away here because it's a really simple calculation. All we're doing is we're taking our infiltration rate from the question, which was 0.75. That's our N value there. And then we're going to multiply that by the volume. If we use our formula then here, N times the volume divided by 3 gives us our CV, which is our ventilation conductance. So if we multiply the air changes per hour by the volume and divide that all by 3, that will give us our ventilation conductance. So again, N is given in the question. Then for our volume, all I've done is I've said if the room is 8 meters long by 8 meters wide and 3.5 meters tall, all I'm going to do there is go 8 times 8 times 3.5 gives me 224. And I can say that CV equals 0.75 times 224 divided by 3 equals 56. Okay, so nice and easy for that one. And then the next part, find the delta T, nice and easy again, we've already done it previously. The only difficult part of this question is that long laborious process of going through all of your fabric losses. Okay, so let's take a look at the final question, or the final formula. So we've got the sum of AU, which we've calculated is 91.36. Onto that we're going to add this 56 for ventilation losses, or ventilation conductance. Remember, all that's saying is if, say this room here had a vent, or even if it doesn't have a vent, you'll have air kind of coming in and out, or else everyone would die. So if you imagine you've got hot air, or just air, the old stank air coming out through that vent, every hour you've got 0.75 of this entire room volume being changed over. So if you imagine 0.75, so like 75% of the air in that room leaves every hour and is replaced by new fresh air. And therefore, that air that's leaving is going to carry away quite a lot of heat, and we're going to have to heat up the new cool fresh air that's coming in. So we're getting a significant heat loss from that. Not as much as we had for the fabric losses, but like significant. So more than half of what we're getting in fabric losses, we're also getting losses from the ventilation conductance here. Okay, then finally we've got sum of AU plus CV multiplied by delta T. The delta T here is just the outside temperature deducted from the inside temperature. So 22 minus 4, the difference between inside and outside is going to be 26. So we're just going to add up our sum of AU and CV and multiply it by delta T. This is where the brackets come in handy. Because if you don't include the brackets, your calculator will try and multiply 56 and 26 first, and then add on 91.36, and it will give you a nonsense answer. So 91.36 plus 56 times 26 gives us, and I can't bother using my calculator anymore, so I'm just going to jump to the next slide, 3,831.36 watts, or about let's scrub off that stuff in the end, about 3.83 kilowatts. So that's that question complete. You might get more complicated variations, but it's always going to be that simple process. The only other thing you might have in terms of extra difficulty would be, say, if the room above or the room below was divided up into more than one room, so you then had to divide your floor or ceiling fabric for your room up into multiple parts. But this is pretty much you finished the standard heat loss question. What we'll do though is we'll jump to a wee bonus question, and we'll look at how changing U values affects the heat losses in the room. So if we look at a wee bonus question here, what is the reduction in heat loss if the U value for the windows is changed to 0.3 watts per meter squared Kelvin? So our U value previously, I think we were doing it 2 based on the limits of the building regs. Then we're going to drop it down to 0.3 and see what happens. Now for that, what I'm going to do is I'm just going to show you the spreadsheet I was using to calculate everything for the previous question. Okay, so here I've got my calculations for that question there. Top box here, I've got all my modified U values that we found at the start. Then I've got my fabric losses just going through the sum of AU, ventilation losses down here, and total heat loss down here in that wee sort of purple highlighted section. Now, for those of you that are unfamiliar with how spreadsheets work, basically what I've done, instead of doing calculations and then typing in my answers, I've had Excel automatically calculate my answers for me. So if I click on this if I go to the north wall that we did and I look at the total area for that, up here in the top, it's a wee bit hard to see, but basically what it's doing is it's multiplying that blue cell by that red cell, and then it's minusing that purple cell there to give me my answer. Okay, so in theory, if we look at this little 15.5 down here, change the colour of that. If I say change the number of minusing to 0, that will automatically change. Okay, so you get the idea. Now, what this means is if, say, like for that bonus question where I want to go back and I want to change my U values for my windows, where are my U values? U values, and my U values for my windows are here, both at 2. So if I want to go and change that based on my bonus question where it asked me to change them to 0.3, all I have to do is change them to 0.3 there and there, and then this should automatically change my final answer. So what I'm going to do is I'm going to take a copy of this previous answer. So there we go. So okay, and I'm going to change that kilowatts to 3.8. There we go. And I'm going to call this heat loss with better windows. Okay, and there we go. Cool. Right, so literally all I'm going to do is change my U values, and this is the same as me going back through the entire calculation again with different U values for the windows. So if I go 0.3, I got the purple one's dropped, and 0.3 again, there we go, it's dropped even further. So stick that in there, so it's at 2.73 kilowatts. Okay, so there we go, we can see what we've dropped to now. Let's highlight that kilowatt section because it's probably easiest to see. So now we went down from 3.8 kilowatts to 2.73 kilowatts. Which check, the question was asking though, what is the reduction in heat loss? So obviously I need to take the difference. So reduction in heat loss equals, and I'm just going to go for that initial value of 3.8 minus that new value, which gives me 1.7 kilowatt reduction. There we go. And yeah, that's that.